Alright, welcome to the first episode of my differential equations and linear algebra class. So we're going to step away from Calc 1 for a little bit because I just got a job as a tutor, and this is one of the classes I'm going to be tutoring, so it'd just be good practice to record some lessons, and maybe some of the people I'm tutoring will find this and maybe find it helpful, but if you're one of those people, just go to Khan Academy. But anyways, differential equations is a course where you have equations with derivatives in it. So you can have something like d, like the second derivative of y plus, I don't know, 3 times the first derivative of y plus y squared equals 3. And these equations with derivatives in it, finding a solution is really hard. And this is what this whole class is about. That's the differential equations part. Linear algebra is with matrices, where you can have something like this, and you'll need to put it into REF form. It's, to be honest, it's like my least favorite class. It sucks. But you'll power through it. It's basically just matrices and a little bit of vector spaces. But we'll get into that later. So first we're going to focus on separable equations. And I'm going to delete this up top just so we have as much room as possible. And separable equations is when you have a derivative and variables of each one. And what we want to do is find a general equation that satisfies this. And in order to do that, we want to get all the x's on one side and all the y's on one side. So let's do that. So first I'm going to multiply both sides by dx, and I'm going to divide both sides by 6y squared. And that way we will end up with 1 over 6y squared dy equals x dx. So now we have all the y's on one side and all the x's on another. And this is helpful because now what we can do is integrate both sides, and by doing that, we can get rid of this dy and this dx. So let's do that. Remember, with our integration power rule, if we have x to the n, then it'll go to x to the n plus 1 over n plus 1. So 6y squared all under 1, and just rewrite that as 6y to the negative 2, and then we just end up getting negative 6y to negative 1. Actually, step back a little bit. It's going to be 1/6y to the negative 2, because constant will just stay the same. And then it's just going to be negative 1/6y to the negative 1. And this y to the negative 1 can just be y to the first in the denominator. And then with x dx, well, that's just x squared over 2. So let's move on. And don't forget your plus c. So now, what most people struggle with this part is the constants. And one, remembering plus c is hard enough, but also understanding that plus c is just a constant. So adding a constant or subtracting a constant to another constant is always going to be a constant. And that's all we care about. We just care that the degree of x or the degree of y is 0. So, right here, if we subtract this constant from this side to this side, well, get rid of it here. And you may think this is just 0, because c minus c, same variable, it would be 0. But this isn't technically like a variable, it's just a variable that represents a constant. And this c doesn't necessarily equal this c. This could be like 30 on this side, 60 on this side. And then you get negative 30 on this side, and that's still a constant. So how I like to think of it is you just choose one c to absorb the other. So we can just get rid of this, and this c eats up that c, and it's still a constant. And now what I want to do is multiply both sides by 6, because we want to isolate y now. So we get negative 1 over y equals 6x squared over 2 plus 6 times c. A constant times another constant is still going to be a constant. So we can just still say plus c. And finally, I want to multiply both sides by y, and then divide both sides by 6x squared plus 2 over 2 plus c. And that way we can finally isolate y. And also, forgot this. Our initial condition, you can find a general formula, which I'll point out once we get there. But initial condition will find a exact formula that applies to a certain c value that you can plug in. It will make more sense in a second. So we multiply both sides by c, and we get negative 1 equals 6x squared over 2 plus c all times y. And then we can divide that by negative 1, and we get y equals negative 1 all over six x squared over 2 plus c. And 6 over 2 is just 3. So now this is our general equation that like solves this. That's what y would equal. But we have an initial condition to account for the constant right here. So let's figure out what that constant would be in this case. So let's erase this. I wish there was a better way to erase, but there isn't. So y equals 1 over 20, and x equals negative 4. So we get 1 over 20 equals negative 1. 4 squared is 16 times 3 is 48 plus c. So now we'll multiply both sides by 48 plus c, and we get 48 plus c over 20 equals negative 1. And then we'll multiply the 20 over, subtract 48, so we end up getting 48 plus c equals negative 20 minus 48. You get c equals negative 68.